Hello and welcome to Alex's Math Help for the people who should be in class, but instead are still on spring break with the band. Today's episode, Dot Products, Day 1. Now chances are you don't remember anything from Lesson 6.1, so we're going to go through a couple of examples to refresh your memory. Okay, well if we delete all the pictures of elephants in the way, we will find our first example. So here we have a vector that is at negative 4, 4, and we're supposed to find the magnitude and the angle measure. We'll start with the magnitude. To get the magnitude, you have to do the square root of a squared plus b squared. And a squared is negative 4 squared, and b squared is 4 squared in this example. And 4 times 4 is 16, and 16 plus 16 is 32. So we have the square root of 32, which can be simplified down to 4 times the square root of 2. And then we move on to the angle measure, which you find by doing the inverse tangent of b over a. So inverse tangent of 4 over negative 4. And 4 over negative 4 is equal to negative 1. So we have the inverse tangent of negative 1. Which comes to equal negative 45. But you have to add 180 degrees because it's in the second quadrant, which gets you 135 degrees. Hooray! You did it! You did it! To reward you for your success, you get not 1, but 2 rhinos! So in this one, we know that the magnitude is 400 and that the angle measure is 200, and we have to find A and B. And to do that, we can just do 400 cosine 200 and 400 sine 200. And it's as easy as that. Except you have to remember that you are in the third quadrant. Therefore, they are both negative. Don't forget that. Negative 400 cosine 200, negative 400 sine 200. Okay, so we're almost ready to go on to the real lesson, but first, it's joke time! A rubber band pistol was confiscated from algebra class because it was a weapon of math disruption. So anyway, the dot product is very simple. You just follow this formula and, here it is. Okay, so all it is that if you have u equals u1, u2, and v equals v1, v2, then if you take u times v, then it equals u1, v1 plus v1, v2. Okay, let's try an example. So we have 4, 3 times negative 1, negative 2. So if we do negative 1 times 4, we get negative 4, and then plus negative 2 times 3, which is negative 6, then we get negative 10. And it's as easy as that. I know, right? Also, on a less important note, if you ever see 2i minus j times 3i minus 5j or anything like that, it just means the same as 2 negative 1 times 3 negative 5. It works for any set of numbers. It's just a different way of writing vectors, and people do it different ways. Anyway, to learn more about the dot products, we can look at this problem. If we have 3, 4 and are asked to find the length, then we obviously do 3 squared plus 4 squared, which always will equal the length squared. That's the formula that we've been using. But now, if we use dot products and are asked to solve 3, 4 times 3, 4, then to solve that using dot products, you end up with 3 squared, just a second, plus 4 squared equals, so yeah, it equals the length squared. They're exactly the same. So that's important to know. Remember, they are the same. Yeah. Okay, this is probably the most important part, so make sure you know this. If you want to find the distance or the angle between two vectors, u and v, in component form, then you've got to follow this formula. So it's theta equals the inverse cosine of u dot v, which is the dot product, over the length of v and the length of u. And those are actually multiplied together. There's not dot product. It's sort of annoying that it uses a dot in two parts of the formula and it means different things. But it's not too hard to remember, so ply. Okay, let's put the formula to the test here. We have u equals 3, 2, and v equals 1, 0. We start by finding the dot product. So we do 3 times 1 is 3, plus 2 times 0 is 0, and that equals 3. Next, we find the length of u. So we do the square root of 3 squared plus 2 squared equals square root of 13, if I can get the 1. There we go. 13. Length of v, square root of 1 squared plus 0 squared, but 0 squared doesn't really matter and doesn't affect it, so just square root of 1 equals 1. Okay, so then the important part, we put all the components together and make the formula. So we have inverse cosine of 3 over square root of 13. Because square root of 13 times 1 is square root of 13. And all you have to do now is use your calculator and find the approximate amount, and it comes out at about 34 degrees, and that's your answer. Alright, next example. See if you can do this one on your own. Pause the video and unpause and check your answer. If you can do it without me helping you, then I'll give you some hippos at the end. Okay, so dot product, we do 8 plus negative 3, because negative 4 times negative 2 is 8, negative 1 times 3 is negative 3, and that equals 5. Sorry, that should be equals, not plus. So dot product is 5. The length of u, we got 4 plus 9, 2 times 2, 4, 3 times 3, 9, square root, equals square root of 13 again. And then for the length of v, we have the square root of negative 4 squared, which is 16, plus 1 equals square root of 17, obviously. And then we plug it all in, and we've got inverse cosine of 5 over square root of 13 times square root of 17 equals, and actually what you should really do is, since you have square root of 13 times square root of 17, you can actually combine those and put them under one radical symbol. So you've got the square root of 13 times 17. And plug that into your calculator, and you should have gotten about 70 degrees. Okay, so if you didn't pause the video and get the answer correct on your own, then close your eyes for this next part. Bam! Hippos! Okay, there's one more major thing you have to know, and then that's it. Now we get to learn about orthogonal vectors, which are, actually, they're pretty easy. Orthogonal basically just means perpendicular, with slight variation, which I'll explain later. Okay, so here's a good explanation that's very important to remember. So the vectors u and v are orthogonal if and only if u times v equals 0. So if we look at two vectors like 2, 5 and negative 5, 2 and ask if they are orthogonal or not, well, the answer is yes, they are. Because 2 times negative 5 is negative 10, and 5 times 2 is 10. And negative 10 plus 10 is 0, which means they're orthogonal. So when you're trying to figure out if two vectors are orthogonal or not, all that matters is the dot product. That's all you have to worry about. As long as the dot product is 0, then they're orthogonal. So like if you died right now, but the dot products equaled 0, you could die happy because it's all that matters. Okay, now I'm going to address the difference between perpendicular and orthogonal. So if you have 2, 5 and 0, 0, the dot product is going to be 0, which means that they're orthogonal. But 0, 0 isn't even a line, so it's impossible for them to be perpendicular. Okay, this is the last thing I promise. Parallel vectors. Vectors are parallel if there are multiples of each other. So if you see a problem like this that asks you to find 3 vectors parallel to 2, 7, then all you have to do is multiply it by any number, like 2. So 2 times 2, 7 equals 4, 14. And for the next number, we could do, I don't know, negative 2. Negative 2 times 2, 7. And that equals negative 4. Negative 14. And again, there's just, you can pick any number. There are infinite choices. And hooray, you're done! That's the whole lesson. So you're all finished now. You survived the first one. There's like 2 more to go, I suppose, so I'll see you next time. Happy face! See ya!